is packed in sterile vials as a powder or suspension. For oral use, it is obtained in tablet form. Before marketed, random samples are collected and they are tested for the quality assurance. As we know, the most common method for quality assurance of the antibiotic is the penicillin bioassay. As you saw in the earlier slide, the bioassay is performed using the plate diffusion assays. Here I would like to mention about the units in which the way in which the penicillin activity is expressed. It is expressed in terms of the IU, which is equivalent to say about 0.6 micrograms of the sodium penicillin, crystalline penicillin G of 98% purity. So quality assays are performed and then it is marketed. You can see the flow sheet of the DSP and then production of semi-synthetic penicillins, that is whatever penicillin is obtained by the commercial process. As it has been mentioned earlier, the 43% is used in the as a starting material for semi-synthetic penicillins, which are having the improved properties, that is they are stability in acidic environment so that they can be administered orally. They have broader spectrum of activity. Many of them are effective even on the gram negative organisms like E. coli, Proteus, Haemophilus, and they can also resist the degradation by the penicillinase, and so they are in these properties they are superior. As you know, some of the important semi-synthetic penicillins are carbenicillin, ampicillin, and the amoxicillin, which is marketed as the augmentin, which is a combination of the clavulanic acid and the ampicillin, and all these are the superior drugs. The production of the penicillin, it requires the enzymatic removal. The enzyme involved is penicillin acylase, which is produced by the mold itself, as well as it is also produced by the other bacteria like E. coli. So that side chain is removed and the 6-amino penicillinic acid is obtained, and then the desired side chain is incorporated by the chemical process, so which results into the production of penicillin. Now that is the present status of the penicillin production, but we know that what is the future. We should consider what may be the future of this penicillin, because the effective chemotherapeutic drugs have resulted into the major problems of the drug resistance and the adverse side effects, and so it is required to get newer and better antibiotics, which sounds almost impossible, and that is because of the production cost and the time which is required, and so the new approaches must be made where one can identify the new target sites. One can develop more economical process like strain improvement, media formulations, fermentation conditions, reactor design, downstream processing. They should be considered and they should be improvised in order to make the economic process. And because the major problems which are facing against the society today in the 21st century is the infectious diseases emerging and re-emerging, and the problem of the antibiotic resistance and the problem of the adverse effects. So these problems would be solved only by considering these new approaches where we can develop the more effective drugs without the adverse side effects. So I have tried my best to give you all the information about the penicillin fermentation. I hope this will be useful for you as study material for your preparation, and you can see the references also that I have made in the slide references. And lastly, I would like to thank the Commissionerate Higher Education Department, and I would also like to thank all the technical staff of the studio who have gave full cooperation, and would also like to thank my colleague Dr. Nupur Goyal, who has helped me in preparation of this presentation and giving this presentation the final shape. So thank you all. A big thank you to all of you, and with this I finish my talk. Thank you very much.
SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.